Recording now. So when we talk about functions, if the value of a variable y is determined by the value of another variable x, remember I told you y depends on x, then y is a function of x. The phrase is a function of means is determined by. If there is more than one value of y corresponding to a particular x value, then y is not determined by x, meaning that I have a repeated x value. So if I have a repeated x value, y is any number, right? So it's not determined by. So that's a definition form. A function is a set of order pairs in which no two pairs have the same first coordinate. First coordinate is the x value. This is why, because y depends on x. And it has a different second coordinate. So when I say this, my order pair, x comma y, x comma, all right, back to this, x comma y, as long as this here is not repeated, right? It doesn't have the same order or same x coordinate, and this one has a different one, then it is a function. The y can have the same for example, I cannot have 2, 3, 2, 4, and it be a function because x repeated. However, you can have a repeated y. You can on the y value in order for it to be a function. Okay, so now let's talk about and in the notes, there's an examples that you can read and look at too as well. So in order to determine if x is a function of b, or excuse me, of y, and in our notes it used a and b, we're going to determine the number of divisors by the positive integer smaller than 100. So it's a lot of reading. So in order to determine if x, which they called it a, b, and y, if these are a function, then we're going to have to determine how many divisors of that number. So if we use 100 divisors of the number, and we can't have a repeated number in order for it to be a function. Okay. Of course, I'm not going to give you, this is just a refresher. It's just an update about functions. So basically saying, in order for us to have a function when I plot it on the graph, I cannot have a repeated x value and it be a function. Neither one of these are functions because we have repeated x values here, 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 here. However, this is a function. This is a function. Okay. We have repeated y values, but we don't have repeated x values. Okay, moving on. So a function is a set of order pairs in which no two pairs have the same x value. Constructing functions, the order pairs in a function can be specified by a variable description, list, table, formula, or graph. The most common and efficient way to specify the order pairs of a function is to give a formula that will produce them. So solving for it. So I got a application problem here. And let me get some more pages. We got application problem from our notes. We're going to construct a function. It's going to try to copy a picture of it. Okay, I'll just have to draw. So we're giving, so let's give some square. A square we know has the same 4 sides, right? A perfect square. And we're going to draw a dotted line splitting it in half, and what happens? I get two right triangles, right? Because if it's drawn correctly, we have two 90-degree angles. So we have two right triangles. So we want to find the area of it. Well, what do I know an area formula for a square? We know that A equals S squared. And that's little s. And since we have the right triangle involved in my perfect square, we know we're going to be using a Pythagorean theorem. So since the sides are all the same, let's just call them S. Of course, that's what we get from our formula. And we know that since all the sides are the same, then we have length times width, which they're the same, gives me a squaring. So now we're going to apply it and we're going to determine what it is. Well, let's label it better. What do we know? Let's call this hypotenuse of the two right triangles D, because we're going to call it D for distance. So let's take our S squared plus our S squared, right? S, and S squared, and we're going to equal it to our D squared, and let's plug in what we know. Well, in order to do anything here, we have to combine like terms. In this case, earlier we had X and Y and they weren't like terms and we couldn't combine them, but we have S to the same power, S to the same power. So these are like terms, so I can combine those. S squared plus S squared is 2S squared. All right, so I need S, right? Because that's what we want to know. We want to know what S is. We got to undo this coefficient on this S squared to a positive 1. So that means I need to divide both sides by 2. Gives me 1. I get S squared is equal to D squared equals 2. So that tells me a little bit. It didn't give me everything I wanted to know, but it did say that our area, again, is A is equal to S squared. So it told me my area. What does it tell me? It tells me area is equal to D squared over 2. So it gave me that much. As long as we don't know the value of D, this is pretty much it. So my area is A squared over 2. Later on, you'll have some values. So that is a function. Domain of functions is the set of all first coordinates. So if we talk about the domain, so moving on to something else, we talk about the domain. It's all X values. And remember when I was talking about the Cartesian coordinates, I said we always read the smaller number to larger. On the X value, we read left to right. So in this one here, we can call it negative infinity to positive infinity. However, if I got it plotted at some point, you know, that may change, but we always read left to right when we read our domain. If we're reading our range is our Y values. And we always read from bottom to top. And again, it's negative infinity, positive infinity. So if I gave you a chart, or I gave you some kind of graph or function, let's draw it. And we got to determine if it is a function. Can y'all tell me if this is a function?
Yes.
Yes, because there is no repeated X value. There can be a repeated Y, but there is no repeated X value. So this is a function. So let's I'm trying to be pretty creative. So that's going to be 3, 5. Oops, that's going to be 5, 3. Right, so we got 1, 2, 3, 4, 5, up 3. Yeah. And let's do, so this should be about the same. Okay, and this point here is 0, 2. This point here is 3, 0, negative 3, 0, 3, 0. All right, so we know all kinds of points. We can find more points than that on this particular function because the arrows keep going. However, we want to know what is its domain. Domain reads left to right. So we're going to start right here and we're going to move our way in. And what do I see? I see this arrow here. And this arrow says we're going out that way. That means we're going to eat all of the negative infinities for the x value. So I already know this part. Keep wanting to write an 8. I already know this part. So let's come back and let's follow it out. We're going to follow it out. And what do I see over here? I have an arrow here, and this arrow is going out this way. That means that it's eating all the positive. Now, if it didn't have an arrow and it stopped right there, then that means it would have been 5. Okay. Let's talk about the range. The range, we start at the bottom and we go up. And what do we see? We have this point here. And at that point, it's a closed circle. It's connected. It's so we know it's closed at that point. Therefore, my range is going to be -2. And I left that off here. -2. So I'm going to follow it up. And when I follow it up, it doesn't matter. As long as one of these arms has an arrow on it, as long as one of them, then that means it's going to eat all the positive infinities. So my range is -2 to infinity. However, if you notice, I put parentheses on this. Parentheses means that we're getting up to that point, but we're not exact. We're not stopping on it. Well, on infinity, we cannot stop on infinity, right? There is no stopping point in infinity. So we're going to always use parentheses. However, I was telling y'all this here is closed at this point at -2 right here. That means that we're not going to use a parenthesis. We're going to use a bracket on this point because we're saying that we include this point. We go all the way to this point. However, the other end of it goes up to the infinity. Well, what is infinity? We don't know. It's continuous. So we need that parenthesis. So this gives me my domain and my range. And this tells me a whole lot about my function. Okay. Let's draw a different one. So what if I have, let's do this. That's a terrible function. I'm going to put an arrow here. Let's call this -1 right there for y. Let's call this 7 for y. Let's call this -5 for x. All right. So if I want to know the domain here, we got to read left to right. So we're going to come in this direction. What do I see at this point right here? That corner point right there is including the value of -5. That means I'm going to put a bracket. And then we're going to follow it out to the arrow, and we see that it goes off to infinity. Now let's do the domain. I mean the range. We come up here. Well, we see this, right? And it went straight across. If my drawing would have been right, it would have looked better, but it should have been more at an angle. I apologize, it wasn't, but it should have been more at an angle. That means this here eventually, it might take forever to go off down to the negative infinities, but eventually, as long as that arrow is going there and this was at a better angle than what I drew, and I promise in your work, it'd be a lot better angles. That means my range is the negative infinity. And then we're going to follow it up. And what do we see here? We see that this line continuously goes out with the arrow on it. So it's going to be my positive infinity. So I know my domain and range of the functions. Is this a function though?
No.
No. However, you can still find a domain and range of it, but it's not a function. All right, so y'all got the ideas about domains and functions or in ranges. I want to talk about a notation. Okay. This here, this F is just a name. It could have been G, it could have been H, it could have been K, it could have been whatever I want it to be. It's the name of this function. What do I know about the function? This function builds on X. No one called me on that one. I think I said Y and I wrote H. This function builds on X that gives me an outcome of Y. Okay, So this is the value of f at x, okay, that comes out with a function notation of y. And again, the f is just the name. It could have been G, H, K, whatever it may be. So I'm gonna see, we got some more problems here. If I said we have, let's use what the book gave. F of 20 is equal to some function of 2x plus 9, right? That's f of x is equal to 2x plus 9, take the square root of it. That means everywhere I see this 20, I'm going to put in the place of x. Or better said, everywhere I see x, I'm going to place that 20 because 20 is my value of x. So now I have 2 times 20 plus 9, which is 49. Square root of 49 is 7. So I know my order pair is 20, 7, meaning x is 20. Whenever x is 20 in this function here, my y is going to be 7. So I can also write it as f of 20 equals 7. And this is using function notation. And that is it of this section, guys.